So far, this mission seems to have gone very well. So Orion is the crew-rated, currently unoccupied vessel that was launched by the Artemis on the Artemis I mission, and is now headed back from the moon.
I was reading that they weren't even testing the life support systems on this mission.
Oh,
they
really?
weren't?
No.
Oh, I thought that was the point.
No, they were testing almost everything about it, but I think they didn't
They forgot to turn the air on.
They didn't forget to. They just were like, we don't need to on this one. They tested it, I think, on the other test flight.
Just why not?
But why not?
Yeah.
Right? Yeah.
Why not turn on the heat and run the air conditioning or whatever you got to do up there?
Yeah.
So it's all just the engineering and
I'm even thinking I would put something in there that mimics human respiration to make sure that
that
you're
would be cool.
consuming oxygen and replenishing it appropriately and cleaning your CO2.
I know they had the mannequins censored and stuff, so I don't know. But maybe I read it wrong, but
they put mannequins in there, but they didn't test the life support.
I think so.
The mannequins are dead.
Well, yeah.
Wow.
The mannequins.
Well, now because they put the life support in.
Yeah.
Welcome to Walkabout the Galaxy, the unpretentious astronomy podcast, where the science is universal, the opinions are personal, and the hosts are ready to partay.
Woo, in the semester. Woo, woo, woo.
We are Strange and Charmed the Astroquarks, also known as Josh Caldwell.
Addie Dove.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram, but not Sunroom, Supernova, or Pear Pop. And I didn't make any of those up.
What?
Pear pop?
Pear pop?
Pear Pop.
How is it spelled? Like a pear that you eat?
Or P-A-I-R?
P-E-A-R, yes.
Wow.
Pear Pop.
What?
Storyboarding is complete for our second music video, which will appear on YouTube sometime before the sun becomes a red giant.
Okay, that's an accurate timeline.
We are also at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu, and definitely do contact us that way if you order a shirt so we can get it to you as soon as possible. We are happy to welcome back to the show Dr. Audrey Martin.
Hello.
Audrey, earlier today, I asked you how you felt about joining the Walkabout crew, and I could not have scripted a better response.
Facts.
Do you remember what you said?
I said, I'm down.
Which is perfect.
It's perfect.
As down is the last remaining quark that has not been astroquarkified.
Yeah. It's perfect.
You are hereby dubbed down astroquark.
Yeah.
I feel like that could have a really not a great connotation, but I think
she's bringing a good connotation.
But I think
to
you
it,
brought a
though.
good connotation to it, so I think it's great.
I'm down.
Yeah, she's thinking up good connotations with her down vibrations.
Oh man.
Mm-hmm.
Our stumper today.
Next music video.
There you go. Our stumper today is energetic, and that's because I just finished.
We're not.
Well, it's because I just finished my course on energy, climate change, and the environment.
Ooh, exciting!
And I totally am on top of all my grading.
Of course, as
and
we all are.
Some of the assignments that students had to complete involved the renewable energy sources.
Excellent.
And so I've been thinking a lot about those. So the stumper today for you two is just solar or wind?
Oh. Full stop?
Full stop.
Wow.
Actually, question mark.
Well, yeah, okay.
Oh, yeah.
Solar or wind?
And you can interpret, the beautiful thing about the stumper, Audrey, down quirk, is that you can get down with it.
I'm going to get down with it.
You can interpret it any way you wish. Any way you wish or wish.
I witch.
You have to go first today.
All right.
Trial by fire.
Solar.
Okay.
Why? Because if I'm outside having a picnic, as one does, and it's windy, it's not as good of a picnic
as if it's sunny. I like it. I like that. Addie, what about
I'm going to go wind.
No.
Yeah.
I am fascinated by wind farms.
And you kind of love violent weather, too.
I do, that's true. But I don't think violent weather is actually great for wind power. Because wind
it's
power,
not great for wind power.
Because wind power wants just more like steady wind,
That's right?
But I And so, like, in the Midwest, in, like, Kansas, occasionally I would drive across Kansas back in grad school because I would go from Colorado to Kansas City, and that just involves driving across Kansas, which is not terrible. I'm from the area. I didn't hate it. But parts of it are super boring. But parts of it had wind farms. And then when I was out in Mojave a couple years ago, there were some super cool wind farms.
They're so beautiful.
They're so fascinating. And, like, now I fly over them and you see them, and you, like, look at them, and you're like, those are some cool windmills. But they're so
huge.
big.
They are.
Then you get passed by like a turbine or a blade.
Yeah, exactly.
When out where we go for rocket launches occasionally, out in the
in
West Texas and New Mexico, frequently we see those turbines, wind blades, whatever, cruising down the road, and it's unreal how huge they are. There are also some really interesting new windmill-less windmills technology that involves like a flow of water mist through you have an opening that the wind is blowing through, and then you have water droplets injected into that opening, and the wind does something, ionization is involved that creates a potential difference. And a test cell of this nature, or maybe several, have been produced that produce tiny amounts of power, but it works. Of course, has the benefits of not having a big spinning giant blade, but it has drawbacks as well.
Yeah, interesting.
It makes me think of a Dyson fan.
Oh yeah.
Right. Yeah.
So sleek.
Fun fact on solar and wind, for if you didn't already know this, and our listeners. So when we're looking at this in my class, can you guess this sort of a mini advanced
Stumper
trivia?
follows.
Yeah. What fraction of the solar energy impinging upon planet Earth
I feel like you should know
would be
this.
needed to supply all of humanity's energy needs? So I'm not talking about, we're not dealing with photovoltaic cells, we're not dealing with reality, we're just dealing with
if we had 100% capture,
100% capture of the energy, or put it this way, what percent capture is needed to provide all of humanity's energy needs, not just electricity, but everything.
Oh, I'm going to be so wrong. 37%.
85%.
So let me just get this straight. You're saying that our humanity's energy needs are on the same order of magnitude as the energy hitting the planet from the sun.
That's why I said I'm very wrong.
I just want to make sure you're interpreting my question correctly, and
surface?
I'm interpreting your answer. No, impinging on the planet Earth.
Yeah.
Forget about clouds.
Just give us the answer. Is it like
0.01%? So
wrong.
the sun, 10,000 times more energy from the sun than what we need. We would need to capture 1/100th of 1%.
I thought we used a lot more energy than that.
That's
exciting.
Yeah.
So why don't we do that?
This is one of the messages of my course.
Oh God.
Yeah.
We should just do
that.
So
let me just
we
make sure.
Just do that, right?
I just want to make sure our listeners understand the ratio.
And watchers.
There's 10,000 times more energy from the sun than all of humanity's energy needs.
No, I'm not going to say it. I was going to make a really snarky comment.
Oh.
So my question was going to be,
please do.
But what happens when we're taking all of that energy from the sun and then it doesn't have it anymore?
Right.
Because this is the thing people say.
Well, one thing people say is that if you put a solar panel here, and I'm indicating where here is with my hands,
of course,
that the spot next to here doesn't get any sun because it's sucked up by that solar panel.
Yeah, exactly. It's stealing it.
Which is not true.
None of these things are true.
This is not true. Well, the 10,000 thing is true.
Okay, none of the things we just said about the energy being taken away
the follow
is a true statement.
The follow-up to the follow-up.
That's awesome.
Isn't it great?
That's so good.
It is. So then you can I don't care my solar panels are 20% efficient. I don't care about clouds. I don't care about this, that, and the other.
Yeah, 20% efficiency still is great.
Yeah. So the follow-up to the follow-up is same question for wind.
But you can't, interesting.
So imagine it, just like, we can have a pretty accurate estimate for the total amount of energy in the planet's wind. And how does that compare to total?
Well, it was 0.01 for...
0.01%. Human energy use is 0.01% of the sun.
Energy use.
What is human energy use as a percentage of all the wind power on planet Earth?
0.1%.
Okay, 10 times.
10 times I think, yeah,
You
there's
think
10
the
times
wind-
less wind than sun.
Got it.
I'm gonna go with 1%.
Okay.
Audrey gets it on the number.
What do I get?
The correct answer.
Yeah.
Yeah.
You get a Walkabout T-shirt. How about
See,
that?
you should have
Hey.
picked wind.
Yeah.
Okay.
Should have
Yeah.
picked wind. I'm just kidding.
I know, I should have. Oh, can I go back?
Yeah.
No,
So-
your answer was more efficient.
So
it was a
even
good choice.
wind, there's 100 times more energy in all of the wind on planet Earth than all of humanity's energy needs.
Wow.
Now, of course, you can't capture it
You know
all.
what the
You
lesson
don't
from
need
this
to.
is?
We should be using more solar and
We
wind
should
energy.
be using more energy.
Right.
Just keep the microwave
Well,
going.
we totally
Yeah.
could if we tapped into all that stuff.
I'm going to turn my AC on right now.
Yeah.
Oh yeah.
Well, today we'll have updates from JWST, S.T.E.V.E., and a weird gamma ray burst. But first, this episode of Walkabout the Galaxy is brought to you by Orion, son of Poseidon and Euryale, maybe? Bringing Orion on your Walkabout the Galaxy, and you'll have nothing to fear. In addition to fighting off any aliens, lions, scorpions, or ancient Greek kings, I should start this
Today's the day.
totally thing over.
The sponsor's going to be
I should
offended.
start this totally thing
You
over,
should.
is what I just said.
Just keep going. Just push through.
In addition to fighting off any aliens, lions, scorpions, or ancient Greek kings who may attack, Orion the Hunter is known for his charmingly boastful conversation and movie star good looks. And he already has his place in the Milky Way with his own constellation. Orion's dog Sirius is available for walkabouts at no extra charge. Sporting a bejeweled dagger and his recognizable belt, and immortalized in the eponymous song by Jethro Tull, let Orion add a little flair to your next voyage. Orion, history in your hand.
Oh.
You'll never get it. Don't even try.
History in your hand.
You can, yeah.
Whenever
related to
we talk
Orion in
about
some
Orion's
way.
belt, I always think of Men in Black.
Oh.
Oh yeah.
Yeah.
Little
The
cat.
cat is named Orion.
Oh, okay.
There's
History in your belt.
in your hand.
So it's
History in your hand. Sorry.
so it's a belt.
It is not a belt.
Is it a
But it's
Palm
related
Pilot?
to Orion's belt
Is it
and his hand.
Is it?
a beeper?
Palm Pilot and Beeper, no.
It's neither.
It's swords. Albion swords.
Oh.
I told you you'd never get it. Don't look at me like that. I warned you.
No, it's fine. I can look at you however I want.
Orion has a dagger, sword
Yeah, no, I get
thing
it.
like that. So
The
yeah.
other thing I was gonna say about that was something and I forgot it. So
Well, Orion splashes down
that's a good segue.
on Sunday, which is
Where
before
is
this
it? It's
episode
splashing
comes
down
out.
like
Near Hawaii.
near Hawaii, yeah. Which is
Oh.
where the Apollos used to splash down.
That's
was out
right.
on that coast.
Yes.
Out in that water, I mean.
That's correct.
That's exciting.
That is exciting.
I really
It's so far
so-
this mission seems to have gone very well. So Orion is the crew-rated, but currently unoccupied
yeah.
vessel that was launched by the Artemis on the Artemis I mission,
Yeah.
and is now headed back from the moon.
I was reading that they weren't even testing the life support systems on this mission.
Oh,
They
really?
weren't?
No.
Oh, I thought that was the point.
I did
No, they
too.
were testing almost everything about it, but I think they didn't
They forgot to turn
They
the
didn't
air
forget
on.
to. They just were like, we don't need to on this one. They tested it, I think, on the other test flight.
Just like kind of why
But
not?
like, why not?
Yeah.
Right? Yeah.
Why not like turn
don't
on the
know.
heat and run the air
Ooh.
conditioning or
Yeah.
whatever you got to do up there?
Yeah.
So it was all just the engineering and
Yeah.
I'm even thinking I
maneuvering.
would like put
Like,
put
there's
something
probably-
in there that mimics human respiration to
Ooh,
make sure that
that
you're
would be cool.
consuming
Yeah, 'cause
oxygen
those-
and replenishing it
Mhm.
appropriately and
Yeah.
cleaning your CO2.
I know they have like the mannequins censored and stuff, so I don't know.
Yeah.
But maybe I read it wrong, but
They put
That's
mannequins
interesting.
in there, but they didn't test the life support.
I think so.
The mannequins are dead.
Well, yeah, the
Wow.
mannequins.
Well, now because they put the life support. in.
Yeah.
So yeah, so it seems like the mission's gone really well. It did its burn to return it to the Earth, and like just the views of the moon have been amazing. I actually heard
Yeah.
like it's been so amazing, right? But I heard a complaint from I was on a telecon recently with a bunch of lunar people, and when somebody complained that there wasn't enough like ahead of time information about what the path would be because we didn't like. So we weren't able to like prepare press releases about where it was going to be looking and like have matching stuff, which is like
Oh.
I think maybe they didn't do that because they just weren't sure how well everything was going to go.
Right.
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 And it seems like it's gone. I mean, maybe there's stuff we haven't heard, but it seems like it's gone really smoothly so far.
Yeah.
And there's like
Yeah.
live feeds from the cameras. Like sometimes it's just still images, but it updates really frequently. And
Cool.
it seems
Yeah.
all the little GoPros on Orion.
So Orion
so
will
cool.
carry 4 individuals on its next flight. Will it be fully crewed? on its next flight with a complement of 4?
Oh, that's a good question.
It's capable of
Artemis
taking up to 4,
2.
right?
Crew. Yeah.
Yeah.
Have they announced the crew?
But we're probably
I think they have.
at
4.
least a year away, and maybe more than a year away from that flight.
Yeah.
So, unlike the space shuttle,
Definitely more than a year away.
the Orion part is the only reusable part of this whole enterprise.
Yeah.
And so,
Yeah.
what is the status of the construction of the Artemis II ginormous rocket?
So it's pretty close, I think.
Oh, that's good.
Like, I don't think... So the rocket isn't the thing... I was reading an article about this the other day. The rocket isn't the thing, probably, that's holding up Artemis II. It's actually some of the flight computers, because they're reusing them. Like, they're between things, but they have to, like, check them out and recertify them and a few other things. And they have to do some stuff to the launch pad.
Oh, yeah. One of the things that I find sad about the whole story, though, with the Artemis, with the Space Launch System, the 4 main engines...
I was going to say that. It is sad.
Those
What
are
happened?
those
The
are
RS-232
those are
now
old
has a
shuttle main
connection.
engines.
Yeah.
RS-232.
The RS-232 engines. Whatever
That's
those are
old.
called.
I didn't know you were old enough to know about RS-232s.
It's still used on spacecraft.
Oh,
Like,
well,
a lot of those are still used on all spacecraft connections.
I'm from back, like, in the days when the printer you might get for your home computer
yeah.
might be an RS-232.
You can still get those, yeah.
In any event, the the main engines on the SLS are old shuttle main engines.
They are.
Which were reused, of course, on the shuttle because they were on the shuttle. They're
Right.
reusable, and now they're one and done and in the drink. And there's only a certain, I don't know, they got 10 or something.
Yeah.
There's 4 per flight. So they got like 2 more flights worth, and then we're done with that. They have to have a whole kind of new design.
Love
So the
engines.
current thing is like Artemis Block 1.
Yes.
And then
So
there's
this
a
is-
Block 1B.
Yeah.
And there's Block 2, and those are going to have a whole different thing because we're just like using these leftover, beautifully reusable engines,
So nice.
and we're
they're
throwing
so
them,
complex,
and we're
too.
throwing them away.
Yeah, and they're just burning up.
And this is, I find this very.
Because the ones they used, the one they
Sad.
launched, Artemis 1, they talked about like the history of the engines they were using, and there was a nice
Yeah.
graphic that showed all the flights.
all the
they were
flights it had
on,
been on, and now they're just at
Now
the bottom
they're-
of the Atlantic Ocean.
and
Oh
or
no,
are
so they can't even be in a museum or...
I think so,
Are
but I
they
don't know.
oceaned or are they burned?
I don't know.
Okay. Yeah, no, probably not. Anyway.
Sad.
Yeah.
But so Artemis is coming back. It's going to splash down in the ocean. This is a big test because there was a long, I don't even remember how many years ago now, but there was an Orion.
Escape thingy.
There was an Orion. Well, they did a little blippy orbital
Right.
test, and then it came back.
A re-entry
A
test.
re-entry test.
Right.
So they went into orbit and then did a re-entry.
I don't think it went into orbit. I think it just went up and down. Went up very, very high.
Oh, maybe it just went up really,
It was
really
like
high.
a very, very high suborb. I mean, it could have been orbital,
But it wasn't.
but it didn't turn right.
It didn't
just
even
went
do
straight
one
up.
orbit?
Yeah, I think it just
Okay.
went straight up and down.
It went up from Florida and then came down in California.
Well, the other one. Well, yeah, that's the way it would have been.
Yeah.
But I don't know where it came down.
Yeah, okay. And it splashed down. But this one is a little nerve-wracking because it's going to be going fast.
Right.
Because it's coming back from
It's
a
falling
big
from the moon.
far orbit,
Yeah.
far orbit, and it's going to be
Yeah.
going fast. So it'll be interesting,
boy.
but exciting.
Yeah.
Yeah.
I think I was going to check to see whether it was going to have a higher actual atmospheric impact speed than the Apollo capsules
It does,
or not.
I think.
Yeah. It
And
won't
others,
be drastically higher. It shouldn't be drastically
Shouldn't be.
higher, but it might be somewhat higher.
Are there going to be CubeSats on Artemis 2?
I don't know. I don't know if they've
Announced
announced secondary
Ride-alongs.
payloads on Artemis
Yeah.
2. They should have. They should know by now. So probably. I don't know. Maybe we'll look that up before the next episode.
Yes.
We'll
Yeah.
update you, dear
Yeah.
readers, listeners. Speaking of crewed flights to the moon,
Yes.
there's this Dearmoon
Right.
flight, which is SpaceX, like a SpaceX test flight, basically, but like a going around the moon as a tourism flight with their Starship.
This is
that
the
was
one that's
announced
sort
from
of
this-
funded by a Japanese.
Yeah, so there's this Japanese super rich person, billionaire, Yusaku. Anyway, Yusaku. I'm gonna mess up his name. Mizawa. And they just announced the full crew for that mission. So there's 8 people.
8 people.
8 people, or maybe 6 people total. Maybe there's 2 alternates.
Oh, okay.
Yeah, I think it's 6 people and 2 alternates. to fly with this Japanese billionaire on Starship. And I forget when exactly they're expecting this mission to happen. I think it's 2023, quote unquote.
Wikipedia says 2023.
Yeah.
Wink and a nod to.
Yeah, and it's the and it's with Starship, and it would be around the moon.
Starship that hasn't launched.
Yes, exactly. Partly because they're still waiting for
FAA
approval to launch, because they're going to make a big mess.
Yeah.
But they've announced it, and so it's artists of various media, so like film, photography, music. One of the like more well-known ones from probably American side is the Everyday Astronaut, Tim Dodd. He does a lot of videos about SpaceX and other things, so interesting.
What are the odds you
cool.
put on whether that will actually launch in 2023?
I'm going to say the same as the percentage of energy that humans use compared to the sun.
0.01%.
0.01%.
Yep. Yep.
Yeah.
I think that's about right. I do think there is a decent chance that they will have their first Starship test launch next year.
I think that'll happen in 2023. I think
looks
with
like they're
humans
getting
on board will
close.
probably be 2024.
Or 9.
I mean, I hope 2024, because Artemis II depends on Starship being able to land people on the moon.
Yeah.
Which this Dearmoon thing would not be landing on the moon.
No, it's just going to go up and go around the moon, I think, and come back.
That would be quite a ride.
It's cool that they're taking artists and not just billionaires.
So his whole thing was that he wants to fly with artists, because it's this like Dearmoon project. They announced from the beginning that that's what it would be.
Yeah.
And that was several years ago that they announced it. And
I guess if you're going to do something like that,
should have sent a poet.
Contact.
Or me. I don't know if I would go on that mission.
Yeah, I don't think I would go.
I would.
You would?
I would do the second round.
Uh-huh.
Or maybe even the third.
Sure.
Yeah.
You know, just in case.
Sure.
Yeah.
And
it would
then
be one hell of a ride, though. And so that, we were talking about the splashdown of Orion in the Pacific Ocean. The Starship is the SpaceX. Makes me think of Flash Gordon. It's this stainless steel clad rocket with fins that lands on its tail like something out of a Flash Gordon or Buck Rogers.
It is very...
It looks ridiculously like somebody made that up.
Yep.
I don't know what Flash Gordon is, but...
Wow. Do you know...
Do you know, like, you haven't heard those words together?
No, I have. I just don't... I just
don't have a picture.
I don't have a picture.
I mean, I never watched it. I just, like, know of it and have a picture, I guess.
Just think of, like, old tiny
SpaceX
science fiction rockets.
Yeah.
Okay, yeah.
Yeah. That's the picture.
You know.
So from Artemis and our space news, we can maybe make a quick jaunt through the JWST corridor.
Yes.
Do we want to start close to home first?
Yes.
Well, I guess there's a quick update, which is just that there's some cool exoplanet spectra that people are ogling. That's like the new
you say
really
ogling?
high.
You don't say ogling?
I say ogling.
I don't know what I say.
Yeah.
Have I ever said that out loud? Ogling? I was going to say oogling, but that...
Ogling.
Some people do say oogling, and I say ogling.
We should all three say it a different way.
Oogling.
1, 2, 3.
Ogling. That sounds kind of nice altogether, actually.
So what were you?
Beautiful.
But then what's our closer to home?
So yeah, astronomers found some really cool clouds on Titan.
Literally and figuratively.
Literally and figuratively, yes.
These
Titan,
are not water droplet clouds.
These are methane clouds. Titan is the largest moon of Saturn, and it's one of the only satellite in the solar system that has an atmosphere. So it's super cool that clouds were found. And what I think is really cool, so they found these clouds with the NIRCam instrument.
Which is one of the JWST instruments.
Exactly.
Right. Okay.
So they got these on November 4th, then on November 5th, also my birthday.
Ooh, that's also my daughter's birthday.
Oh my god. Yeah, then on November 4th, they were like, oh my goodness, this is so cool. Again, literally and figuratively. And so they reached out to an Earth-based telescope, Keck, which is in Hawaii, And they got more images, and they found the same clouds, but they had like kind of moved, or not necessarily the same clouds, but clouds in the same
Conceivably.
place
Yeah.
Okay.
that had like, you know, moved a little bit. And so they're seeing this, you know, cool kind of atmospheric effects going on, which is really exciting. And I think they have time later in the year to get some spectra, so they're going to figure out the exact composition of the clouds and everything, which is going to be cool.
What kind of like atmospheric circulation does Titan have?
It's pretty
It must be
static.
really static, right?
Yeah.
Because otherwise they would have moved in 2 days or a day or whatever
Yeah.
it was.
So Titan,
Because it has a
It's-
really nice
it's-
thick atmosphere. It's
its
very
atmosphere is very dense.
proto-Earth-like.
yeah, it's about 96% molecular nitrogen,
Yeah, it's very
and then
earthy.
most of the rest is methane and ethane.
Not so earthy.
Not so
And
earthy.
methane, natural gas, as a reminder for folks who may not be familiar. So the stuff that you use for your grill
How much?
is actually droplets in the clouds of
Yeah.
Of Titan.
Yeah, they have a
So-
methaneological cycle.
Titan
Yeah.
is
It's a
tidally
hydrological
locked
cycle.
to Saturn, just the way Earth's moon is tidally locked. So its rotation period is equal to its orbit period.
So it rotates
I,
pretty slowly.
I believe that its orbit period is about a week.
Oh wow,
Oh, that's
Um,
faster than
that's
I
pretty
would
fast though.
think.
yeah, it's around a big planet,
Yeah.
which means it's got a lot of
Yeah.
gravity, so
Yeah.
it has to be moving very quickly
Yeah.
to orbit it. Its orbit is bigger than the moon's, but it's orbiting something that's got
Yeah.
100
big-
times the mass of the Earth, basically.
Yeah.
So I might, maybe it's 9 days or something, but it's on the order of a week. So it's got a slow rotation. It has a thick, heavy atmosphere. There's not a lot of, you don't have the kind of solar differential
Yeah,
forcing that we
right.
have on the Earth. We were talking about wind power for the Earth earlier. For Titan,
Not
for
so feasible.
Earth, a lot of it.
But there's all that methane we can use on Titan.
Yeah.
Yes.
So
Whole lakes.
Yeah, but I mean, one of the reasons there's a lot of wind on the Earth is because you have this contrast between the oceans and the continents, which
Yeah.
develops differential heating, and that drives atmospheric circulation.
Yeah.
Titan first, it's 10 times farther from the sun, so the sunlight is very dim. The atmosphere is very hazy, in addition to these
Yes.
clouds.
It is.
So what I love about these pictures
That we're looking
is,
at.
Yeah.
is that we can see the surface of Titan kind of,
Yeah.
which normally
Yes.
that's very, very difficult to see, and that's what JWST is so great, is that it's looking in the infrared and it can look in wavelengths where that atmosphere and haze are not quite as opaque.
Yeah. Yeah, most of the images we have of Titan, if they're invisible, if they're in the visible wavelengths, are sort of that hazy, yellowy, almost Venus-y looking kind of pictures, and then
Just like a
other
blob.
pictures we have do show the surface, but those are radar.
Right.
But
Which are
the
not-
infrared ones are kind
Radar
of
is so different
Yeah.
than visible that it's like, okay, that's cool, I can see shapes, but it doesn't give you that sense of like, what would it look like to me?
Yeah, it's hard to interpret as well.
Yeah.
You're just
Yeah.
like,
There's some interesting clouds.
Things are
Yeah.
bright, and you're like, that doesn't really mean bright, it means rough.
exactly.
You know? And this is dark, that doesn't mean dark, it means smooth.
Yeah.
Yeah,
You know?
it's
So,
Yeah.
let's
Cool.
see, before we, is that the last one, JWST corridor?
Yeah, I mean, yes, I think that's it for now.
So on our way out of the JWST corridor, I will accost you with some old school trivia.
Oh.
So
Okay.
just old school random trivia to welcome Audrey to the ranks of the official astroquarks.
Woo-hoo.
So I have 3 trivia multiple choice questions for you.
Of course.
Okay.
Okay.
And this nothing listeners delight, and you as well, Addie. Nothing tortuous
Great.
or complicated about these questions.
Okay.
Oh no.
That's
No,
good.
nothing.
That's a
That's
good
okay.
thing.
That's good.
Okay.
After
okay,
visiting
okay.
the moon, several Apollo astronauts famously reported that moon dust smells like what?
Oh, am I supposed to answer?
Oh,
You're
no.
not. Your choices are gunpowder.
Oh, there's multiple choice.
It's multiple choice. Gunpowder, mothballs, diesel fuel, or melting plastic. That's one. Second, which of the following is not a name of a geographic, I should say
You
selenographic,
should.
location on the moon? Is it the Sea of Clouds, the Ocean of Glass, the Sea of Nectar, or the Ocean of Storms?
Okay.
And finally, the
These are tricky.
Donjon scale of brightness
la
measures
la.
the brightness of what?
Can you spell that?
Danjon, but I think it's a French individual.
Yeah.
Is it sunspots, supernova, lunar eclipses, or comet coma?
Okay.
Those are your questions we'll come back to.
And these are supposed to be easy.
No,
And
they're
I
not,
should
supposed
know
to
them.
they're not supposed to be convoluted.
Not
They're not necessarily easy.
Oh,
They're at
got
least
it.
easy
Okay,
to
cool,
understand what the hell I'm asking you,
Yes.
which is not always the
Beautiful.
case.
Mhm.
Frequently, my trivia questions involve a long, complicated introduction, and at the end of it, you're like, what's the question again?
Oh yeah, like last
Like
time.
last time.
Yeah.
Right.
Yes.
Perfect.
Yes.
Okay. Yeah. Great.
Okay, so,
Steve?
Steve.
Steve. So I am new to S.T.E.V.E. I learned about S.T.E.V.E. today.
Yay!
S.T.E.V.E., which stands for Strong Thermal Emission Velocity Enhancement.
I actually could not remember. I don't know if we've said ever what it stands for.
I think we have.
probably did in the way back.
I think we have.
Okay.
I like I don't remember where in this article they say it, but they call it a backronym,
Mm-hmm.
which is just a
Right.
fun term that I'm going to try to use all
Yes,
the
I
time
love
now.
using that.
There are lots of
There's
those
lots of
out
acronyms.
there.
Messenger.
So a backronym is you come up with the acronym you want it to be and then figure out some technical words that make it fit.
Work.
Right?
Yeah.
Mm-hmm.
We do
Yeah,
that a
and
lot.
I guess so. Citizen scientists essentially found this really cool auroral feature,
Right.
and initially called it something, but then because they didn't know what it was, they didn't want any confusion around it, and so they just called it S.T.E.V.E. And
Wait a minute. I thought they originally called it Steve?
well, I
Just
think
for
they
funsies?
called it something about a proton
Okay.
aurora or something like that, and then scientists said no, it can't be a proton aurora, and so they're like, okay, we'll just call it S.T.E.V.E. then.
Okay.
Okay.
And so hence S.T.E.V.E. So they found this cool auroral feature and were able to image it from multiple locations in Canada.
So this is something that looks like Aurora, but it's not. The main
Yeah.
Aurora is sort of like a big loop around the pole,
Mm-hmm.
around the magnetic pole, that's glowing upper atmospheric gases caused by charged particles plowing into it from above.
Correct.
And this is some glowing region that's separated from that oval.
Yes.
So like Steve's, we've talked about Steve's a few times, and we see them. We've seen them from like orbit, like in ISS but we mostly see them from the ground, and they're like sudden event kind of things that are like big streamers that are like usually purpley, I think.
Yeah,
Yeah.
purpley. Yeah, that's exactly right. Purpley streamers.
Whereas our typical auroral oval is red and green.
Yeah, a lot more.
And
I think there are different altitudes too.
right. So this is called a subauroral arc.
Yeah.
And I'm not sure whether sub means at lower latitudes or lower altitudes, or both.
Latitude. I don't. Wait.
Anyway. Oh, this is good.
Good dead air.
This is good dead air, everybody.
So
Yeah, go ahead.
no, so it's a separate feature from the main auroral arc.
Uh-huh.
It was observed by citizen scientists. So these are people who are making.
Citizens.
What did I say?
No, you're right. She said they are citizens.
Got that one.
And then the non-citizen scientists
Are not citizens.
they're not citizens.
They are citizens, but they're like...
I don't know. I was like, okay, you're citizen scientists. What does that make me? So,
That's true.
Wait a
What are
minute.
we?
right. I'm a citizen, I thought.
Citizen.
Went
on-
back and looked at data from spacecraft
Yes.
and were able to say that these were actually features that had been seen before. Right?
Yeah.
Right.
Mm-hmm.
Yeah, it's interesting because there's this swarm spacecraft, and then they're all that like is sort of flying through and mapping some sort of fortuitous mapping of these regions.
So they seem to be related to something called a subauroral ionic drift, which is itself its own acronym.
Yeah.
SAID,
SAID.
SAID. And so then they said, oh, this is the emission that goes with that. And that's what led to the bacronyming of
Yes.
S.T.E.V.E.
Yes.
Yeah.
Yeah, because Steve, that's right, because Steve has never actually had a name before. We haven't ever said that name because it didn't have a name before. They just recently
Oh.
backronymed it.
We just called it some weird emission.
No, they're called ST.E.V.E s.
I know,
but
now.
that wasn't an acronym before. It was just called ST.E.V.E s.
Oh.
And now
Why
they've
was it called
backronymed
ST.E.V.E?
it. I don't remember.
Oh, come on.
But they were called ST.E.V.E s. That was just what they decided to call them. Yeah.
Well, the paper acknowledges the citizen scientists who made this possible, which includes the Alberta Aurora Chaser Facebook group.
Oh.
So, you know, that's kind of cool. That, you know, these folks are... And I was looking at...
there's a lot of observations like Aurora and other things like that people... and even observations of like planets with telescopes that people do from the ground. And there's been a lot of good like amateur networks like that for a long time. But there's more of this sort of getting involved in the citizen science and getting published papers and stuff like that now, which is pretty awesome.
Yeah. Cool. There's some cool pictures of this stuff too, and they sort of linked it together with... I've never seen Aurora like that.
I've never seen Aurora.
I've never seen one either.
Yeah. We
Florida's
all
not
need
the
we
great-
need a walkabout trip to Iceland or
We
something.
need in the dead of winter.
Yes.
Okay, cool. Strong Thermal Emission Velocity Enhancement, or ST.E.V.E, the acronym.
Yeah.
Yeah.
Steve has a backronym now. That's exciting.
We'll try to post some pictures. Steve shows motion both westward in both purple and green colors, and I think they don't really totally understand the purple emission. So what determines these colors typically in auroral emission is like just the energy levels of these charged particles are coming in, they're hitting oxygen or nitrogen molecules and causing certain energy transitions, just like neon, or I shouldn't say, like fluorescent light bulbs.
Right, yeah. There you
Of
go.
a particular color have a particular composition of gas in there, and the Earth's atmosphere has a particular composition of gas, so when you hit it with some charged particles, it should glow that color. And now all of a sudden we got this new color.
Yeah.
Purple.
Yeah.
Yeah, and we've been talking about ST.E.V.E s for a while, but it's exciting that there are like sort of these newer observations, and we're starting to understand them a little bit better.
I keep thinking Steve Holt.
I don't know what that is. You don't know Flash Gordon, I don't know Steve Holt.
Perfect.
Good. Should I
Okay.
explain?
I don't know. Is it interesting?
Yeah.
Yeah, it's from Arrested Development.
Yeah, you should
It's
know
a
it.
character.
I should know
Steve
it.
Holt.
I should know it.
You've seen that show.
Well, there's also some very cool, pretty red, blue, and purple colors in our last story about a weird gamma ray burst.
Yeah.
And so the issue here is gamma ray bursts are these very brief bursts of gamma ray radiation that we see with our gamma ray telescopes, and they've been connected to a certain kind of supernova. And historically, their gamma ray bursts sort of come in very short or longer forms.
Yeah.
The longer ones are about 2 seconds, so that's the relative.
Yeah.
Short and long is relative here. So a long gamma ray burst is a couple of seconds, and a short gamma ray burst is much less than that. And they appeared to be connected to different types of source events. And now, 2 telescopes have seen a short burst, 50 milliseconds, 0.05 seconds, that looks like it came from what we presumed was... Oh, I got this wrong.
I think yours, yeah.
I said this backwards, but
Yeah.
it's a short GRB and long GRB's clothing. As,
Yes.
Lisa Grossman
It lasted
describes it.
50 seconds.
50
That's
seconds.
forever.
I'm sorry, I totally had that wrong.
Yeah.
I said 50
Milliseconds, but it was 50 seconds.
50
It should have been
whole
less than
seconds.
2 seconds, and it lasted
Yeah.
50 seconds.
I see.
Yeah.
So a very long
Yeah.
burst, but it looks like it came from what's called a kilonova.
Which we've talked about in the past.
Right.
And typically have really short bursts.
And the kilonova is the collision of 2 neutron stars,
It's
right?
a merger.
Yeah, and those are super exciting because that's how we get some heavy elements like gold, and we had a kilonova observed with the LIGO Gravitational Wave Observatory not too long ago.
Typically often makes a black hole
Right.
when you have these collisions, and then you get this short burst of energy as it's
Right.
happening. Yeah.
Yeah, so, okay, right, so that short violent event should produce a short violent outburst of gamma rays, but in this case, it looks in the visible light and everything else like, oh, that was a kilonova, merger of 2 neutron stars. That should produce a very short gamma ray burst, and this one was almost a minute long.
Yeah. So they have both the kilonova detection and the gamma ray burst detection, which puts them together for the first time. There's been some outliers in the past, but I think we didn't
This
have
one
the
is ironclad.
kilonova the merger observation at the same time as the gamma ray burst observation. So
Right.
this really makes it ironclad. Yes, so that's exciting.
So what's the explanation? So it looks like a kilonova, which is a merging of two neutron stars. In this case, they're suggesting possibly some other sort of merger.
Yes, it looks like a neutron star merging with a white dwarf. Is that?
That's
Yeah.
one possibility.
That's one possibility.
Yeah. Yeah.
Or that a neutron star collided with a black hole, with an
Okay.
existing little black hole.
I would have thought that would do.
And
Why would that take longer?
Because
Yeah.
eating the black hole, eating the star, actually
Just
takes
takes-
a little bit longer.
Because it's so massive.
I don't know.
Is it
I
because
didn't
it's,
see much. I haven't read the full
I,
explanation.
yeah, so it's spiraling in and coming across the event horizon. So at a certain point, some of that energy is trapped inside the event horizon. You don't see any of that.
Probably, yeah.
If you have two neutron stars, there is no event horizon
No.
until after you have your
You just-
merger.
Yeah,
So you don't have anything exciting going on until they smack
until
together.
it happens, yeah.
And then maybe with a black hole, you've got the whole spiraling in the black hole's accretion disk.
But the authors of the
Oh.
paper think it maybe is that the one we mentioned first,
The white
this-
dwarf.
which is sort of a newer idea, which is the neutron star merging with a white dwarf, and that would produce a kilonova if it was a big white dwarf, which they sort of have size
Right.
limits, but a heavy version, and then it would potentially produce a magnetar.
Magnetar.
And that's just a neutron star with a
It's
strong
highly
magnetic field.
magnetized.
So instead of, I guess
So
what
that's
gets
what
you here,
extends the burst.
earlier we were just saying, let's talk us through this, Josh. The two neutron stars merge to make a black hole. Once you got the black hole, you've got no light getting out from that source object.
Right.
You can still have energy from beyond it, but in my simple-minded way, I can understand how that
Sure.
leads to a short gamma ray burst. If you merge it with a white dwarf, your product isn't massive enough to become a black hole,
Uh-huh.
and then this resulting magnetar is able to keep energizing the
Yeah.
material around it to keep ongoing source
make it
of
longer
gamma
than 2
rays
seconds.
for
It's
50
whole
seconds in this
seconds.
case.
50 freaking seconds.
Yeah.
Yeah.
But this is some ideas, and they don't fully know yet, obviously, but they'll do some more observations and modeling. But this is important because these kinds of things help create things like heavier elements, and they
Right.
create lots of
Yeah, and if we've seen now potentially a new kind of merger than one we've seen before, unfortunately, I guess LIGO was offline at the time
Yeah.
of this. So
But it'll be back online in 2023.
yeah,
So
then
maybe
this
we'll
has
see
to happen
another
again
one.
now.
Yeah.
yeah.
LIGO,
Put it on the
Yeah.
calendar.
get yourself online. All right, are
Okay.
you ready for your straightforward trivia?
I'm so ready.
Addie is very ready
Sure.
for the first one. She remembers the question and she knows the answer. I don't even need to read the choices. What's the answer?
Gunpowder.
Yeah,
Gunpowder.
yeah,
That's my answer.
yeah.
That's the
Okay.
only one I'm 100% sure
Right,
about.
yeah. Let's
Okay.
get that.
That
one out
was
of
what
way.
the Apollo astronauts said moon dust smelled like.
Yeah, which is interesting.
It has to do with the
It's-
fact that moon dust is actually pretty reactive
Yeah.
on this because it's got a lot of fresh bonds on the surface, and so it basically gets into it reacts.
It's not.
and makes-
It's interesting, but it's not
Oh.
actually a good thing.
It's not great.
It's not good that it smelled like gunpowder. It's not good that they could smell anything because that meant it was in their
Right.
lungs.
Yeah.
Yeah, that's bad.
Some of them had
That is
hay
bad.
fever-like symptoms after
Yeah.
smelling the gunpowder.
Okay,
The
second one.
moon dust.
Audrey goes first. Which of the
Okay.
following is not a name given by astronomers to a selenographic location, meaning a location on the moon?
Mhm.
Is it A, the Sea of Clouds, B, the Ocean of Glass, C, the Sea of Nectar, or D, the Ocean of Storms?
Oof. I'm gonna go with the Sea of Glass because there was only
Ocean of Glass?
or the Ocean of Glass because
Mhm.
there was only a bit of glass that was found. That
And whereas there's plenty of nectar.
there is so much nectar on the moon, but there is a little bit of glass.
I just love
There
how
is a
you
little
approach
bit of
this. You're
glass.
like, let's see, clouds, nectar,
Yeah.
storms, or glass. What is there the least of on the moon?
Glass.
Glass.
Wait, that is on the moon.
I don't understand. What's the problem?
Yeah, I like it.
I locked it in. Glass.
You're still locking it in.
I was either gonna say the first one or glass, clouds or glass.
Clouds or
I think I'm
glass.
also gonna say glass, but not because
What's
of
your
the amount
reasoning?
of glass. It's because I know there's the last two I know are there,
nectar and storms.
Nectaris Basin.
They go.
and
They go by their Latin names.
They all go by their Latin names.
Right. Which
And
are
I think
real.
that there's a Nubium, there's a Nectaris, and I think so I'm gonna go with glass.
Okay, you are both correct.
Yeah.
High five. Yeah.
Because there's no glass.
That's not why. That's not why. That's not the
these
case.
are all
Because there
names-
is glass.
No,
No.
because they're
It's
all named
because
from
that's the one
back
that
in the
got
day.
made up. That isn't the one that's there.
Yeah, but what's the clouds in?
Mare Nubium
It is Nubium. Okay.
and Mare Nectaris and Oceanus Procellarum.
Procellarum. Yeah.
Oh.
Okay, finally, the Donjon scale of brightness measures the brightness of what?
I feel like it has to be eclipse because all the other questions were moon questions.
Oh, interesting.
Mm.
But I don't know. What
So,
were the options again?
eclipse-
Can you remind us? the options?
Sunspots, supernovae, lunar eclipse, or
That's
comet comae.
Mm.
Latinizing my plurals.
Yeah.
I don't think it's comet Kome. I don't.
Just pick one.
Sunspots.
I like it.
But are you going with sunspots
No, I'm
also?
going
You're
with
going
the
lunar
one.
eclipses.
Mhm.
It is lunar eclipses.
Ah.
I
But
was
it
like,
was
why
totally
else?
accidental.
Oh, but all of
Wasn't
the.
it?
I mean,
know.
what would be the tying thread between all the questions?
None. I told you
otherwise?
these were just random, simple.
But they were all moon questions.
It was not deliberate. It's an accident.
Wow.
Hmm.
Yeah.
Yay, me!
It is
I
lunar
win
eclipses.
today.
I put that one. I thought that was going to be the big stumper because lunar eclipses seems a very odd thing to attach a brightness scale
Yeah.
to.
I agree, but
Yeah. The brightness
it is.
scale goes from 0 to 5.
okay. Sure, say
Great.
0 to 1
The
first.
Donjon scale, 0 to 5, and there's no decimals, so it's all whole numbers.
Oh.
Yeah. 0 is the very dark one, and 4. Oh, I said 0 to 5. It's 0 to 4.
Unreliable.
It's
4, 5.
It's 5 levels,
They're
but
the same.
IDL counting.
Inclusive.
And 4 is very bright copper, red, or orange eclipse. Yeah.
Interesting.
So,
Cool.
and those things can be affected sort of like by global atmospheric conditions. Like if we have a giant volcanic eruption, it puts a lot of dust in the upper atmosphere.
Have we
That
talked about
affects-
Mauna Loa?
No.
Mauna Loa is erupting. All
It
the
is.
Keck and the other telescopes are
Yeah.
fine, but it's interesting. The
My
saddle
brother-
road might get cut off.
My brother sent some cool pictures because he was
Is he
filming,
filming in Hawaii?
Oh, I'm
Oh.
so jealous. I want
Yeah.
to see an eruption.
Yeah.
That would be so cool.
I've been to Mauna Kea. No,
Mauna Kea is where the
Mauna Kea is where it's.
observatories.
Oh yeah, I've been to the Mauna Loa. I've been to the part that's been erupting for a while. That's in Volcanoes National Park.
Kilauea.
Kilauea. There you go.
Right.
That caldera.
Yes.
I've
I've
been
been to
there
that.
too.
Isn't
Yeah.
that this one?
No, this is a different one.
Oh, I thought it was that one.
No, it's a different part.
Okay.
Kilauea and this other part. Mauna Loa hasn't erupted since like the 80s.
Oh, it's the giant other
It's the
very
big,
tall
very
mountain
flat one.
next to
It's the flatter one.
It's the one that looks like the one with the telescopes on it, but it's
It's
dormant.
next to
Oh,
it. Yeah.
no.
Yeah.
I totally was
That's
like,
so much cooler.
It's so
It is so
cool.
much
There's
cooler.
two things erupting right
That's
now. There's photos
amazing.
of where you can see a heat expressed from both of them.
Wow.
we totally know what's going on. here.
Mm-hmm.
Come on.
While it may have felt like the meeting I had just before this recording, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel. Our videos now feature chapter markers, so you can skip to the good stuff if you are lucky enough to find it. Catch up on old episodes wherever you get your podcasts. Follow us on Rutroll.
At walk_the_galaxy.
And ask us questions at wtg@ucf.edu. Our theme music was composed by Richard Garusik. Production assistance is provided by Logan Basinger. Thanks to our listeners in Washington, State and D.C., and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Audrey Martin.
We're the astroquarks, signing off until the next episode of Walkabout the Galaxy.
Explosions.
Eruptions.
Eruptions. That's